In this video, we will see Testbench of SV, which is our FIFO, is our module in this video, and I will run this. And I will tell you a new method with a configuration which you will not see in the website most probably, because modern Testbench use this configuration class. I am not saying that is wrong, but it is a good method that you can use. And yes, we will also see coverage. 99% scores our test cases are passed, and coverage, let's see, 100% functional coverage is there. Okay, so first we need to learn how our Testbench architecture is.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
So our Testbench has our top module, and in that module all these things are there. All the components are inside this top module, and this top module has, first thing is our program block, which is new block we will use. It is not in our UVM Testbench video, but we will use this video for explaining this program block, which will be running in reactive region because of timing related issue. Rest of the things are class inside our program block, but before that, the top has our TB top is our program. Second thing is our interface. Interface has its proper syntax, and duty is our module. So these three things are static in nature, which will communicate with this virtual interface. You can see driver to interface is our virtual interface. I will change the pen. This is our virtual interface, and virtual interface is a pointer which will be created in runtime, because this test and all other components are classes, and these other things are static domain. So both communication is done with our virtual interface. We will see that, and you need to understand that everything is inside one layer. So like top has module, inside that has our program has our test has our environment has these four things, and interface and duty are the separate things. This config is our object. It is a class which will be created at runtime. This packet is also a class which has all the signals, and package has separate syntax. It is a separate thing. Files inside that. So we will include this one time, and we can get every classes there. So let's move forward with our Testbench. Here is our Testbench. Module of FIFO I have explained in my previous video, so let's go directly to our Testbench. So first is our TB top. As I said earlier, we have included all our three things like duty, our program block, and our interface. So let's go to our interface first. This is our interface. Interface is our simple read, write, data in, data out. All the FIFO signals are there, and when we have get this global signals from our TB top, which we will see now. This is our global signal logic, I reset and I clock, which I have also generated in our TB top as well, because it is global signal, and simple code for that, like clock is not of clock, not bitwise operator, not bitwise operator clock, because it is logic, so we can use that. And our design we have included here, and as I said earlier, we have passed our I clock and reset in our top. So that reset, and see, this is input logic for that, because our FIFO will get this logic from our interface, and this will pass from our TB top, then means top module, our Testbench top, and this will go to our interface, and interface will send it to our duty. And this is static nature, so it will directly communicate our FIFO, all the signals we have taken in our Testbench. Yes, and this program block we will have our interface passed to our program block, because all the Testbench should know where is our interface, because we are communicating within them. Okay. Rest of the thing is simple as module, like we have just initial begin for this task and so. So this is important things. Now let's go towards our main thing is our program, which is new. Program in program is our syntax. Here we will include our package. In UVM Testbench we included this in our TB top or Testbench top, but now we will use program block and have all the package, because after this program block all the classes are started, and we will import the package as well. So first we will see package. See, package has some hierarchy structure, as I said in our Testbench video, but I will explain again. This is our first thing, is our objects we have created, because packet should be known by every class, because we will passing this package to our duty. Configure, we should configure first. This hierarchy is about the connections. So first packet, then configuration, we will make connections, then scoreboard, then our coverage, then our input output monitor, then our driver, then generator connection will be there, environment connection will be there, and then our test connections will be there. So you can also think about building. So first test will be built, then environment will build, then generator, then driver, and this is our basic element. So whenever you create your first testbench, you should create up till driver only. All the connection and everything syntax you can check. After that, you can add our monitor, coverage, and everything. These two things can have to be created first. Okay. So I will first tell you about configuration. See, this configuration class is simple class. All the things which will be passed throughout the environment you can write here, as well as you can have, like, if you have created two scoreboard, you can write here scoreboard, and you can on and off with the help of if else condition. You can configure that which scoreboard you want. Okay, so whatever thing you are passing throughout the environment, you can use this configuration class and configure your environment as well. So virtual interface I will passing throughout the class, and as well as our mailboxes I have created here. So in program block also we will create our configuration class, and we will pass this configuration in test. So we will take test handle. So where is test? See, we have created test, and this handle we will pass to our test class. The rest of the thing is this phases, build, connect, and run phase. We will create this whole three phases. And initial begin, we will just create our means give our memory to our configuration class, and we will pass this class to our test. Okay, and this is our connection, config.inter equal to inter.fifo, means our interface is connected to our configuration class and to our duty. This thing is our connection. So run test is our method. We will run the test, and here is our run test. You can see run test, it has our environment class handle, our configuration class. So we get this configuration handle with from our program block here. See, here we have given to new, and in new constructor we get this handle, and this is configuration config handle, and we will equate this with our new handle in test. On this new handle we will pass to our environment. So this thing will go on until our generator, and we have our connect phase, and we have a run. And so I have run method of the generator before environment, so you can also run in your environment, that is also fine. See, so after that is our environment class. Environment class. So this is our environment class, and environment class has these four things, as I said earlier. In this video I have taken input output monitor to show, you can use that also, and scoreboard and coverage. Packet you can use here or not, we don't need this in this class, but okay, it will not throw any error because handle, it is our object. And configuration class, similar to last time, we will also we will get this from test, and we will pass this to our generator with the help of new method. Then we will build all those things, and then we will connect this all things, and we will also run this. And now you can see fork and join, so everything can be created parallelly. It doesn't depend on step by step. Environment, after that we have generator. Before generator we will see packet, because we will create packet in our generator. So packet is simple class. Read write is our signals inside our duty, and our data, we will send only one data in because we are randomizing that thing, and this is our simple packet class. So in generator, now see, this packet class is our object, so we haven't passed it anywhere. We can just write there and include in our package, and we can use anywhere. Generator. In generator we have our mailbox, which we get from our configuration class. We have written in that, and packet, we need packet, so we will have packet handle, and data in data for our passing the data or keeping the data. Similar to that configuration you have understood, I think, passing and getting that. GND is our mailbox, so we give mailbox a memory. Here only you will give memory from where you will send the data, and in driver we will not create any memory for our mailbox. And you can use in build also, you can also create this thing in our function also, that is also fine. And connect phase, we will connect this driver from our mailbox, from our generator to driver mailbox to our configuration, because it has configuration handle, so we will also have this path in connection, therefore it is connection. And this task run, we will run this task for 500 times, and this is our task name read write, and this is whole our process. So first we have given memory to our packet, then we have randomized our packet, and then we will give our data to our data in. Similar thing will happen throughout the generator. We will give read write signal, we will put this our packet to our mailbox, we will give this packet to our driver, and I will get that work. Similar thing we have done again. Okay, just create new memory again, just rewrite thing, and same thing. You can write display statement in creation of your test bench. It will help to debug up till where your test bench is working. Now after generating, we have driver class, we have the similar or same mailbox here, but we will use here get method, because in generator we have used put method. See, both are the blocking method. Where see, here is our put method. Now in driver we will have our mailbox, similar thing for our configuration, and packet, because we are taking the packet from our mailbox, we will need a packet handler. And virtual interface we will need, because we will send this virtual packets from driver to interface with the help of virtual interface. Configuration is same as always. We don't need this build phase in driver, because there is no other component after driver, but if you want you can create. Then connect phase, we will just connect here. See, we are connecting configuration class mailbox to our this mailbox. Okay, so you have to remember how you will use left hand side and right hand side assignments. Here also we have run phase, and interface we will have at this side, because we are getting this packet to our interface, and where we are getting this packet from our generator to driver mailbox, and we have used our get method and this packet. So you can see I haven't created any new packet, because it is already created. We are just taking that packet from our mailbox, and we have used this delay, because for synchronization, that is interface clock, that is a global clock we have passed from our TB top, and this synchronizes that every passage of clock we will send some data, and we are getting this data after processing from interface to our design, then it will go to again interface, and we will take the data from input monitor or output monitor. So input monitor and output monitor are same, so I will explain only one thing, that is output monitor, because we are getting output from our output monitor. So mailbox we have created from output monitor to scoreboard, and as well as, if I have remembered, I have also created for our coverage. Okay, so packet we need, because we will get the packet. Configuration is same as always, and this is our mailbox creation here, because we will create here mailbox and send the data, so we will use put method. So where is that put method? This is our put method, created packet. And now let's see, that passage of clock and driver is after sending the packet, and this passage is before getting the packet, because it should synchronize. If the both of them use same cycle, then we will have multiple datas at the same time, we may have our data loss. So synchronize that properly. For our begin, we will get our packet, and we will send this to our scoreboard. Simple. Similar to your input monitor, same thing, configuration, everything, mailbox. And see, here we have used coverage mailbox. I have used coverage mailbox. So coverage mailbox, we will create memory, and we will send this to our coverage, and all the data is here in both the input monitor. You can get the data, because both are taken from interface only, so that's fine. Okay, same logic. So send this to our coverage class. So first we will see our scoreboard. So we are getting this both mailbox input and output monitor, inputs from our input monitor, output from our output monitor. Configuration is same. We will create two packets for comparing one packet with another. Same thing for our configuration class, connection between our interface from our configuration class. Then run phase we have forever begin, and simple thing to compare is our packet 1 to our packet 2 data, means data in to data out. We will get this both from our input and output monitor, and get this packet 1 and 2 and compare that. If it is compared, then we will have declared our pass and fail. We have declared static, because class is our dynamic entity, so it will create new memory every time, but when we declare it static, it will have the same memory which will add the pass values. So we will pass these values, and you have seen this displays in our display in our terminal. See, and pass and fail values with the help of and our packet class. So these are the same displays. All the packet are displays, and match then pass values are printed. See, this is the printed values, because both if and else, then we will print both the values, and increment will be there. Simple. Now the new thing is our coverage part. That is our last thing. And input monitor we will get our coverage, and here also I have taken two packets and one cover group and n cover group with our CP and cover point. It is our simple syntax: one cover point for one, second cover point second, two packets, read and write. We will clear that we have bin of b1 and b2, and it should be 0 to 1. And after that we will create our configuration class and have our connection between the coverage and run task. So in run task we will have forever begin, and it will calculate that our coverage is covered or not. Okay, so this sample is our syntax which will display our coverage. So thank you, and you can comment me for new video.
Please Lord, give me a sign, a sign.